Hello, everyone. Please have a bit of patience. We'll start in a short while.
Jeet, we can start. We are live on YouTube.
Okay, thank you, sir. Okay, I think most of the participants have joined. Some of them are joining. So we are already live on YouTube. So good evening, everybody. And good evening to the honorable guest speaker from Palo Alto Network, Mr. Mandeep Singh. Good evening, Mr. Mandeep Singh. Thank you, sir, for accepting our invitation. So while the session is being carried out, I would request all the participants to raise their hands in case you have any doubts or questions. Okay, you can write down your questions in the chat box and we will direct them directly to our guest speaker for today, right? So let us, I think we can start the session. We have already 48 participants who have joined this call. So
yeah, so thank you, Mr.
Sir,
G.
just a minute. Sir, I'll introduce you and you can start after that. Okay. So just a minute, sir. So hello, good evening, everyone. We are back with another edition of SOET Equity. I welcome you all. This digital session is presented jointly by the Department of Electronics and Communication Engineering in association with its IETE Students Forum under the School of Engineering and Technology at Adamas University, Kolkata, West Bengal. So today our topic of discussion is industry evolution, fundamentals of container, Kubernetes, and associated security. I am happy to share with you that we have a renowned industry speaker with us today. He will share with us his perspectives on this subject. We are delighted to have with us Mr. Mandeep Singh, technical consultant at Palo Alto Networks. Mr. Singh, good evening, sir.
Good evening, G. Thank you so much.
Mr. Singh, on behalf of the Department of the Students Forum and our school, that is the School of Engineering and Technology, I would like to convey our sincere gratitude for agreeing to share this evening with us. Thank you, sir. Thanks a lot. Friends, I would like to take this opportunity to introduce Mr. Singh to all of you. Mr. Mandeep Singh currently works as a technical consultant, digital native vertical in Palo Alto Networks. He has over 19 years of industry experience. Before Palo Alto, he has worked in companies like Cisco Systems, where he was a part of the system engineering team for 13 years as technical solution architect, security. And in TCS for over 5 years, Mr. Mandeep Singh holds an MBA from Guru Gobind Singh Indraprastha University. He holds various industry certifications like CKA certification, CEH, CCIE, TOGGR, RHCT, and etc. So it is very clear that we have an industry stalwart today with us. Friends, we are fortunate to have Mr. Singh with us today. He has kindly consented to share with us his perspective on many interesting topics like journey towards cloud, what is Docker, Kubernetes, and why we need these technologies. What is the need of security in cloud environment? I am sure, like me, all the participants are eagerly waiting to hear from Mr. Singh. So, friends, let's hear it from Mr. Singh now. Mr. Singh, may I request you to share your valuable insight with our audience here? Currently, we have 50 participants, members who have joined this Zoom meeting, and numerous others who will be viewing it live streaming on our Adamus University YouTube channel. So, Mr. Singh, it is all over to you. All the best, sir. Thank you for accepting our invitation.
Yeah, thank you. Thank you, Mr. G. Thank you so much. I hope you are able to see my presentation and my voice is clear.
Yes, sir. It is audible and it is very clear. Your presentation is visible.
Okay, all right. Thank you, everyone. Thanks for taking out the time. And, I'm delighted that, so many participants have joined this call. And I'll try to do my justice in terms of, enabling with you with my vast experience in the industry, right? The idea is to basically, walk you through about, you know, uh, the industry evolution, right? I mean, what we have seen in the past 3 to 4 decades, how industry has evolved all the way from mainframe computers to cloud computing today, right? What are the new things in the industry today? I mean, what are we talking about, or what our customers are in fact, interested in listening from us, when we have a meeting with them. That's where this Docker container comes into the picture, and followed by the automation, the orchestration of the new environment through Kubernetes, and probably one slide towards where I will talk about that, how Palo Alto Network is helping its customer secure secure this new type of environment per se, right? So before even talk about the cloud computing, I would like to walk you through how the industry has evolved. And when I talk about industry, I mean, when I talk about evolution, this evolution is multifold, right? One is about from the software development lifecycle perspective. Second is about how applications have evolved today. What are the deployment and packages options available to our customer? And last but not the least, in terms of the infrastructure, right? So with that, let's quickly touch upon the deployment process of it, right? I understand that most of you are from the engineering background, and many of you might have heard about the SDLC, which is a software development life cycle, right? And you definitely must have heard about waterfall model. So waterfall is essentially a software development life cycle, which in fact divide the entire development process uh, into a multiple separate phases, right? So there are bunch of phases through which the development process through. And the one thing which is notable for this particular process is that it is sequential in nature, right? One phase act as input to the next phase, right? And only once a particular phase is over, the information is handed off to the second phase. And once it reaches to its last phase, that's where the feedback is sent back to the very first phase, right? So it is sequential in nature, right? The input of one is in fact the output of the previous phase per se. So this has been very delayed deployment life cycle, and because of this process, development has been very slow, and it at times used to take years for a particular application to be delivered for users to start using it, right? And at time we have seen that once a customer has given a requirement, probably during the requirement analysis, and when the developers are writing the codes, customer often change their requirement, so the entire process used to go for a toss. That's where the agile development life cycle came into the picture, where the developer engage customers early on, right? And the benefit of it is it was to essentially have the feedback coming directly from the customer at the early stage, make the changes, and deliver the application to customer fast. uh, the new thing which we are seeing in the industry today is about DevOps, right? So as the name says, DevOps is essentially a combination of development and the operations team. So what essentially it does is that in the DevOps, the development team and the operation teams come together, right? Development teams often write their software codes in a particular environment, right? Whereas when it comes to the production, the environment is altogether different, right? So there are challenges in terms of after the code has been written, operation team used to face a lot of challenge in terms of deploying, operating and monitoring such solutions, right? So that's where this DevOps come into the picture, right? The idea of DevOps was to manage end-to-end engineering process, right? So from there, from the SDLC, let me probably quickly talk about the application architecture, right? Probably 3 decades back, we used to have a mainframe computers. Those computer applications were mostly monolithic in nature, which essentially means that one application used to have everything into it, right? So, which means that a small modification in a code might require a rewriting of the complete software, right? And which actually used to lead to scaling of the application, right? And from there, industry transition to N tier, we call it as a 2-tier or a 3-tier architecture, depending upon how the application is written. At time, we used to have just the front end and the database. And in many cases, we used to have, the front end, the app tier and the database tier, right? So idea was to, segregate the functionalities, leverage the resources which are available in the various servers and make application more agile. However, today, what we are seeing in the industry, the way the industry is transitioning, they're transitioning to microservices-led applications. So microservices essentially, addresses all the challenges, the industry used to face with the monolithic system, right? And how it does it by virtue of, modularizing all the application, right? I mean, whatever is possible within the application, create a module out of it, right? So that the complete application has got less dependency on a specific function. So if we take an example of a retail website like Snapdeal or Amazon, or from wherever we do the online shopping today, you see that the moment you log into a website, there are a catalog which is available to you. You have an option to select a lot of products of your interest, right? Then there is a cart. You keep on adding what is that you are interested in buying to a cart, and then finally you do a payment, right? So all of these function, while it looks as a one application you are accessing through the browser, it has got various moving component at the back end. And that's where this microservices comes into the picture, and they are playing its role. So what happens, right? Suddenly when a retail business ran a campaign, right? Maybe towards Diwali or towards, December, towards, the Christmas time frame, what they do, right? Suddenly they realize that there is lot of load onto the, the payment portion of the application, right? So rather than rewriting or rather than scaling up the complete application, they can scale out only that function which is under stress, right? So that is what the benefit microservices give to the customers. From there on, moving on to how applications have been deployed in the past, and where we are moving, or where we have moved, and how it is maturing further. So initially we used to have a physical server dedicated for the application, which essentially means that all resources associated with the server, whether it is a CPU, memory, network, storage, all used to be dedicatedly allocated for that particular application. So
Sir,
application.
may I interrupt you for here at this point for just a minute? Sir, while teaching students, especially undergraduate students in networking courses, I have found that some of the students are unable to understand the physical meaning of a server. So can you please explain us the physical meaning of a server? What is a server and what all does it possess? Okay.
All right. All right. No problem. So when we talk about server, right? I mean, I am pretty sure that, most of the students must be having a personal computer at their home, maybe some form of an iPad, and so on and so forth, right? These devices or these gadgets are designed for consumer business per se, which essentially means that the the OEM, the original equipment manufacturer, knows that how this device is going to be used. However, when it comes to installing a application onto the server, they need a enterprise grid hardware, a hardware which is able to sustain probably spike in the voltage, right? They need a storage which has got a very fast storage connectivity in terms of RPM, right? Both in terms of read and write, and then extra powerful CPU, because applications are CPU intensive. So when we talk about hardware, or when we talk about server is a physical enclosure, right, in which various electronic components like CPU, right, multi-core CPU, a huge amount of RAM, altogether from probably 32 GB to it can go up to like 1 TB today, right, of CPU, of memory. And from the storage perspective, it has inbuilt storage, which starts from probably 1 TB of storage all the way to 50 TB, or the bigger one even have higher storage locally available in the servers per se. And these storage again are of two type, right? These storages are either either a spindle base, right, which is a standard SATA hard disk, or it is a SSD, which is a solid state drives, right? The difference between the two drives is that the spindle base has got low RPM, which essentially means that the read and write, the IOPS, right, input output processing, IOPS is lesser in spindle based hard disk with respect to the SSD. And at the same time, the failure rate, we call it as a MTBF, mean time between failure, is much higher in SSD types of hardware with respect to the spindle base, right? So it looks, it from the component perspective, they are exactly same what you have in your laptops or your desktop, what you have in your home. However, the scale of this or the scale or the size of the components is far bigger and larger when it comes to server standpoint. One thing probably which I wanted to add here is from the storage perspective, depending upon how big the application is. For example, if it is a database, if I'm talking about a database, the local storage might not be good enough. So when we design the solution, we look at whether the local storage is good enough, whether it provides enough of resiliency, high availability, fault tolerance, which an application need. If it does not, then we go for a SAN, which is a storage area network, or a NAS, which is a network attached storage, hooked on to the server to provide the extended need of storage, right? So from there, I will move on to the virtual server. The challenge with the physical server is that when an application is installed onto the server, all resources are going to be dedicated for that particular one set of application. So there is lot of unnecessary wastage of resources was there, right? Because when we used to design the server, we have to consider the peak, right? The peak could be a spike, for example, like I mean, if there is a university, if there is a college, the college has got a average utilization of the server. However, during the exam time or during the result time, all the students try to check their result during this at probably at the same time, or probably within the same window, because they wanted to know their result ASAP. that's where the load comes onto the server, and that's where sizing comes into the picture. So when we used to design the server, we used to consider that particular peak which that this particular server has to stand to. But during the off peak hours, all the resources are goes for a waste. And that's where industry transitioned to concept of virtualization, right? And you might have heard of the company VMware, who is pioneered into the virtualization. And then we had another companies like Microsoft, Red Hat also came into, and then they have their set of virtualization software as well. What is virtualization? So virtualization is in fact an abstraction of software from the hardware, right? So the underlying hardware is abstracted from the software. Software runs independent. The layer in between the hardware and the servers, right, relies on a layer which is in between, and this layer used to make the applications feel as if they have a direct access to the server, right? Whereas it don't used to be. So there are benefit in terms of multiple application can coexist, can run simultaneously on one's physical server. That's one. Second is that it used to give a inbuilt fault tolerance capability, which means that if a physical server fails, there was the ability for a virtual machine to automatically move to the second server which is available, right? Okay, all right. So from there, right, I mean, still, I mean, when we talk about virtualization, when we talk about multiple application running onto the same server, there used to be huge amount of resources being consumed by the application, and application still have multiple moving part within it, right? So when we run a virtual server, it used to take not days, definitely, it used to take days in installing a application in the physical server. However, when we moved to the virtual server, it was fast. It moved from couple of days to couple of hours, but still couple of hours were there, and a lot of resources were being used by the virtual server itself, right? So industry thought that how can they further optimize the utilization of the resource, one. And second is that from the microservices perspective, how could they essentially leverage this microservices more? And that's where the container comes into the picture. So I will double click on the container in my subsequent slides. And last but not the least is about the infrastructure per se. So we had a dedicated data centers for organizations like I mean the bigger organization like I mean TCS of the world, Infosys of the world, with so many applications running, they had no choice but to build a dedicated server, a dedicated data center for themselves. But try to understand that it is not just the data center, the associated infrastructure by virtue of providing the power to the data center, the cooling, a backup as a generator, and so on and so forth, has to be arranged for the data center so that the applications can be hosted in that data center. And from there, industry moved to the hosted data center, where the service providers, they host the infrastructure, and it used to be borrowed by the organization. And from there, now the challenge of having hosted infrastructure is that you still have to hook through some mechanism to start accessing the application. So if it is a data center, let's say it's a controllers data center, or it's a NIC data center, for you to start accessing the application, you have to through some mechanism hook on to the NIC data center. That was its limitation, right? So from there, organizations start evaluating, embracing the cloud, right? Cloud is something probably I mean I have a slide. I will try to double click on that as well there. But the idea here is that how the services can be made available from anywhere, anytime of the day for the users. So this is how has industry evolved in last three decade or so, right? And And in this presentation, I'm going to touch upon cloud computing, and I will be touching upon containers per se. So moving to the moving to my next slide. So what is cloud computing, right? I mean, as I was essentially telling you that we have a data center, we any which way can use hosted data center, but what is this cloud computing help us with? So cloud computing has got two words in it. One is cloud and second is computing. So when we look at computing, it essentially means providing us the resources we need to run our application. This is is covered from the computing perspective. When we say, when we look at the word cloud, the cloud essentially means, I mean, it don't just literally go by the word cloud, it is in the cloud. The cloud means that the resources, this computing resources are available to you irrespective of your location, irrespective of the time you try to access, whatever the device you are trying to access those applications, right? So cloud computing is a computing which relies on sharing the computer resources, right, rather than having dedicating the resources for a particular set of a customer, right? So it's the another analogy which we used to give to our customer is that it's a utility based model, right? I can give you some examples around it also. A lot of organizations who are into development, so they have the development environment, and then there is a production environment, and then there is a third environment which we call it as a staging environment. So developer used to develop the software or the application. It used to be staged in the staging environment before it is actually put it into the production, to be sure that it is going to run the way it is expected. But think of the fact that when we have these three different set of requirement, the organization need so much of a hardware, right? So they need a dedicated hardware for the developer, they need a dedicated hardware for the staging, and they any which way need a hardware for the production environment. Now the developer environment, the development environment is required for only some time. I mean, till the time the software is being under development, right? I mean, it is only at that time you need the resources. However, once the development is done, probably you can reduce your resources from 100% to 20-30 odd percent, because you are just going to be fixing the bugs. With the traditional architecture, it was not possible. Cloud computing gives customers a liberty to scale out or scale in, right? They can go to a cloud service provider, uh, ask for the resources which they needed day one, can put a barometer as to I mean, how far they will be able to scale out, right, in terms of increasing the resources, how far they can go, and when the resources are not needed, what is the minimum, which is scale in, right? So that is what the cloud computing gives us. And second is that it is a utility based, which means that whatever you are using, you are going to be paying for that much resources, not not otherwise. So just a basic concept on the cloud computing per se. When we talk about deployment, it is broadly divided into four different model. One is a private cloud, second is a public cloud, third is a hybrid cloud, and fourth is a community cloud, right? So first I will touch upon the public cloud, and then I will move on to the private cloud. Public cloud is in fact means that you as a customer do not bother where the cloud service provider resources are, right? So you just use your internet to hook on to the cloud service provider, like for example, Amazon or Azure of the world, configure or onboard your servers or onboard your applications per se with the required number of server resources, and start working. You are least bother that I mean, who is sharing that same resources, right? Definitely there is enough of isolation and security being taken care by the cloud service provider. However, you do not you do not have any concern in terms of sharing the resources with other customers per se, right? That's where the public cloud comes into the picture. But when we talk about federals, when we talk about government customers, right, they do not agree to it, right? They say that, I definitely cannot afford to share my resources with enterprise, right? Because I have a confidential data, I have more critical data, and I can't afford to lose that data. That's point number one. And point number two is that I cannot afford to cross the boundary. I can't have my data moving out of the country, right? There are regulations around, the data integrity, right? So that's where the private cloud come into the picture. Private cloud again can be on-prem, right? Altogether developed by the customer themselves, or it could be a service provider led as well, right? So as you know that for defense, AWS has got a dedicated cloud for defense DoD in America per se, right? So when we talk about private cloud, right, NIC has got their own set of a private cloud. Control-S, there are many other service provider who are offering this private cloud services, and they have their data centers within India only, and they ensure that data doesn't crosses the boundary. Hybrid cloud is the environment where uh, you know I have an application, and I can only allow certain set of applications to be hosted in the public cloud. Rest of the application, I wanted to keep it close to me, right? For example, database, right? And other set of application which I wanted to have it with me in my private data center. However, the front end, right, and other non-critical applications can be hosted in the public cloud. The combination of public cloud and on-prem data center is something known as a hybrid cloud per se. And then is about the community cloud. The community cloud is something like uh, 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 a cloud where organization from the same industry, right, they share the cloud, and then they uses the community cloud there. uh, Now, looking at the services model, right? Now, these cloud providers, whether it is a public cloud or it is a private cloud, they offer you various services model, right? One of the service model is infrastructure as a service. Second service model is platform as a service, PaaS we call it as. And third service model is software as a service. We call it as a SaaS, right? So I'm not touching this on-prem. This on-prem is something which is the traditional data center which you have in your facility, right? We are focusing here on these service models, the service model offered by the cloud service provider per se. Now, in this particular slide, you could see that there is a blue color, light blue color, and then there is an orange color, which essentially depict the responsibility. On the basis of service model you pick, you may have certain responsibility as a customer, or you may not have anything, right? So let's just quickly look at infrastructure as a service. When you say infrastructure as a service, the service provider, the cloud service provider, will give you the the hardware resources which you need, right? Which means that the required CPU, RAM, storage, networking for you to create an environment. And then the virtualization layer, because you are definitely going to leverage virtualization. You are definitely going to virtualize your environment and run multiple servers on one physical host. Dedicating a host is not a good option in cloud per se. So there is a virtualization layer, and you can run multiple applications onto the server per se. You will never ever get to know that what is underneath, right? That is all being controlled, managed by and maintained by the service provider themselves, right? When you have infrastructure as a service, you are responsible for bringing in your own operating system, whether it is a Linux based operating system or it is a Windows based operating system, and the application with the dependencies, whether it is a middleware, runtime, and you are responsible for your data, right? What is that you are going to do with the data? When an application is running, a data is being generated by the application. How do you want the cloud service provider to handle the data? The responsibility of the data lies with you, right? You want it to store within the cloud service provider, you want it to download it to your data center, that's your decision. And then comes this platform as a service. With platform as a service, the organization focused only on the application, right? They do not want it to spend their CPU cycle, the human resources, for managing the underlying networking, which anyway was not here as well. However, in terms of talking about the operating system and the applications, the middleware per se, right, the runtime, the the customer, the organization will just focus on the application they wanted to host in the cloud service provider and the data. And then is software as a service, right? The SaaS based offering. In the SaaS based offering, the SaaS vendor gives you everything, and you just start you just start accessing those applications. The one good example is, like, for example, Zoom. At this point in time, we are using Zoom as an application for video conferencing. We are running our call through the Zoom. So we do not know what Zoom is using underneath, but the services are available to us. Similarly, Gmail, Facebook, right? Salesforce.com, right? So and so forth, Office 365. These are few of the example of SaaS-based applications which are there in the industry. So, friends, I mean, so one is the deployment model, second is the service model, but definitely there has to be something underneath, right? And that's where this particular slide talks about that service provider, the cloud service providers still need a hardware. They still have a hardware, right? They are still using some kind of a hypervisor layer in between, so that they can run they can offer this service to their customer, and then their customer can run multiple application onto the same physical host, right? So definitely they have the physical hardwares with them. They do care about the hypervisor. This could be anything. Just don't go with the VMware. It could be anything, KVM, Red Hat KVM, Hyper-V, whatever it could be. But the idea is to virtualize the hardware, abstract the hardware from the software, so that you can run your own application along with its associated operating system, right? And then uh, cloud essentially means that you have some sort of a self-service portal. So you log in to the cloud service provider self-service portal, enroll yourself, give your payment option, I mean, the credit card detail, right? And then start building your environment by, installing the operating system applications on top of it, and start, giving access to either to yourself or to your customer from the outside world, which is internet. And then there is a billing system. Since it's a utility based model, which essentially means the amount of time you have used their resources. The resources could be physical resources could be a logical resources like public IP addresses, because since this is going to be available to consumer from the internet, you need some kind of a public IP address, and that is being offered by the cloud service provider. So you have borrowed the public IP address from them also. So not only the utilization of the physical hardware, right? The non-physical thing which you have utilized, for example, the public IP, things like load balancers, all of that are being calculated on various parameters, and you are being charged, on the basis of the consumption. All right, friends. So with that, I will move on to the Docker, right? What is Docker and why the Docker is, right? So I think I'm running late, so I have to be a little fast here. So this particular slide talks about that, when you have to move your cargo, right? And the cargo, I mean, when you have to, transport your cargo, and cargo could be of any shape and size, you would need a transport to accommodate that size, right? And it would have been very difficult for you to optimally utilize the transport, right? And that's where the industry came in with the concept of container. So you must have seen the container. I'm talking about the physical container when you are shipping your cargoes, right, to outside India, right? We generally use ships, and these ships have a standard size of containers in which you can dump in your cargo and it is going to be shipped, right? By virtue of the standardization being done on the container, right, the underlying transport is also standardized. So we have trucks or lorries which can exactly fit the containers. We have the trains which can exactly fit these containers, and any which way we can stack a lot of containers in the ship for export to the various other countries per se. Same analogy we can use it in the IT world as well. We have been having various requirement of the softwares, and these softwares, as I told you earlier, being developed by our developers using their own set of environment. They had their own development virtual machine, they had their own set of servers, right? Which may or may not be same as what we have in the production environment, right? And that's where the compatibility issue comes into the picture. The development team says that the application is running fine. The operation teams claims that no, it is not running the way it is expected to be. They have to look for a lot of compatibility things before they make it available to the consumer per se. And that's where Docker container, now the word Docker container, not the physical Docker, but the Docker container comes into the picture, which essentially ensures that whatever the developer has written, it can be packaged in a container in a such a way that it can run smoothly, on any of the underlying infrastructure provided by the customer in the production environment per se. So what is Docker? Docker is nothing else but a piece of a software, right, with the complete file system, such a way that it has everything it need to run, right? So it's something like a wrapping of the software and its dependencies. Software is the code which is written by your developer, the runtime it need to run that application code, and the system libraries which are dependencies wrapped in a small image, so that it can run in an environment per se. So this particular slide talks about the difference between the container and the virtual machine. So on the left hand side, I have a representation of a virtual machine where you could say that we have a physical server, we have a operating system, which is a hypervisor. At time there is a hypervisor, at time there is a operating system as well. So both the combinations are available. Host operating system is not mandatory, but you definitely need a hypervisor to do a virtualization of your infrastructure. But if you really see application A running has got all its associated binaries and libraries in addition to the guest operating system. So how big or how huge this image is going to be? Definitely, multiple of 100 gigs, multiple of 100 MBs, right? And gigs at time, this virtual machine is. And if you have to run another copy of it, you have to, take a replica of it and run it, which essentially means that if you were consuming like 1 gig of a storage for this particular virtual machine, the same instance, the copy of it again need again a 1 gig of a storage perspective, and RAM and all that is extra per se. But when we look at the container are lean in nature, right? When we talk about container abstract are further abstracted in such a way that they just have the application code which you wanted to run, its associated binaries and libraries, and a minimum or a leaned layer of operating system. There is a lean layer of operating system, definitely not shown in this, but you could see that there is a lean operating system running within the container to make that particular app available, right? And if you are running a multiple copies of the same application, the dependencies and the operating system can be further shared, which essentially means that if hypothetically I take it as this container consumes around 50 or 100 odd MB of a space. The second copy of it is going to be just 10 MB, hypothetically. So that's what the benefit container gives to our customer. So it is very easy for organization to bring up or bring down the containers with respect to the virtual machines. Yeah. So how does container look like? If you really see, there's something known as a manifest, which is nothing else but a Docker file. And in the Docker file, you write how the container image is going to be created, right? This Docker file is generally a YAML file, right? Or it could be a JSON file as well. And in this JSON file, you write what is your base image, which is a lean base image. What is your middleware? What are the dependencies like OpenSSL, and then your load, and then your code. You layered all of these. Now this layering, the capability of layering the base OS and the libraries and the dependencies is something uniquely done by Docker container. And that's why they exist into the industry today. So you write a Docker file, which is a JSON and a JSON or a YAML file, which has got all this information, and an image is created. Now this image is I would say it is a static, right? It is not running, right? It doesn't have a write option at this point in time. You can just do a read of the image, but for you to start accepting the request from the consumer, you have to run the container, and that's where Docker, running the Docker in a Docker environment comes into the picture. So you have the running instance of the actual Docker in form of a Docker container. And when the container is running, that's where they have the read and the write capability. So when you have made any changes, let's say, you wrote something, right? Some changes has been done. That read and write option allows you to rewrite or use it to create another image, so that, you would have to kind of, reinvent the wheel again and again. Moving on, this particular slide talks about as to how developer basically create an image and then put it into the run environment, right? So there is lot of open source thing which the developer use, like whether it is a base image or it is the dependencies or the language they want you to use, right? So they pull this thing either from the Docker hub, right, or some form of other registry. So you could see here that the the developer pulls the Ubuntu image, right, or nginx per se, and has all the other dependencies being written in the Docker file and built a image. Once an image is built, it is being orchestrated by some mechanism and run it in the environment, in the production environment as a container. So any question at this point in time before I move on? Okay, all right. So with that, I'm moving on to the Kubernetes, right? So we now, I think all of us might appreciate the fact that why we need the containers per se, what are the benefit of the containers. But managing container is a tough task in itself, right? It requires a lot of humans in terms of looking at the high availability, looking at the fault tolerance, looking at how the scale out and the scale in works. And that's where the Kubernetes comes into the picture, right? Kubernetes is a automation or a management platform which provide resiliency and self-healing capability to the container environment. So you still need a container. Container could be from companies like Docker container, or it could be from the companies like Rockets, right? So the underlying containers are going to be there, and those are going to be orchestrated by a management platform. We call it as a Kubernetes. Kubernetes will help us give scale out or scale down of the Docker containers, right? So the moment there is a requirement of increasing the number of containers, Kubernetes will automatically spin the containers for you to take care of the load. And once the load goes down to a certain threshold, it removes the containers, right? Uh, when we talk about container, unlike virtual machines or unlike our physical servers, where we do a lot of patching and where we do a lot of upgradation of the operating system, containers are immutable in nature. They are considered to be running only for a couple of minutes and then they go away. So that's why we do not have to kind of think about upgrading the containers whenever there is a need. Let's say there is a vulnerability which has been identified and container needs to be upgraded. Developer rather create a new Docker image and run that image, and start forwarding the traffic to the new containers rather than upgrading the older one. Once it is tested working fine, the older containers are going to be removed from the production environment. All this is done gracefully. So it's a 100% open source, right? I mean, it was done by Google, right? Most of the work on the Kubernetes is being done by Google, and from there it went to the community per se. But the idea here is that it is written in a Go language, right? And it can support multiple Docker runtime, which I was talking about, whether it is a Docker or it is a container D per se. So when we talk about Kubernetes, right? Kubernetes has got its own set of concept where we talk about the nodes and the cluster. Nodes are the physical server on which the container runs, and multiple nodes form a cluster, right? So if you really look at it, what I have created is a hexagon, and in this hexagon, all the containers are running. But these containers are not available to anyone, outside. For the containers, for the application to be exposed to the outside world, within the Kubernetes, there is a concept of services. One has to, write or, create a services to expose the applications which are running on the containers, right? That's the second concept. The second thing is that from the Kubernetes perspective, there is a master, there is a worker node. Worker node is the one where the runtime actually runs, where the container runs, and master is the one which does all the orchestration and the management part of it, right? And it has got various functions like etcd, kube API, controller, and so on and so forth. So this particular slide talks about then that when a administrator wanted to manage the cluster, right, they have to be in touch with the master. They cannot directly access to the nodes, the worker nodes where the runtime is there. They will access all the nodes, or all management is being done by through the master. User access to the API server, and API server is the one which is talking to the various component which are running within the node. So if you really see, there is something known as a kubelet, and there is something known as a networking part of it. These are the bare minimum two services which are running, right, for master to manage the nodes. And then apart from that, there's a container runtime, which could be a Docker or a Rocket running, so that we can start hosting the containers on it. So this particular slide basically talks about, when we talks about container, in the container world, right, they have their own small set of a network which allows the container to talk to each other. But when they have to talk to the outside world, they utilizes the IP address of the server. So you could see that for containers, there is a separate set of a IP address range, and from the physical host perspective, there is a separate set of a IP address. For the containers to talk to each other, there is a logical switch which is there within the server. But if they have to talk to outside world, that's where they utilize the physical host IP address. This was the requirement of Docker initially. But when Kubernetes comes into the picture, Kubernetes says that the pod should be able to talk to each other within the node or outside the node without the NAT. And that's where the network layer within the container comes into the picture. So there are various solutions available. One is like Weavework or WeaveNet, Flannel, Calicum, and then from various other companies as well. What essentially these solution does is that whenever the container has to talk to the other container in the other host, they utilize the plugin which is running on the node to communicate to the node in the other host per se. And from that, I will move on to the DevOps, which is continuous integration and continuous development flow per se, right? So this particular slide kind of summarizes what we have just gone through in terms of all the way from application development to the application deployment by our operations team. So here you could see that there is a developer who has got a Mac. He has got his own set of operating system running. Developer does is that what he or she does is that he uses the language, right, to write the Docker file, right, and then that Docker file has got all the information which we have learned in the past. Compile that in form of a Docker file, create an image by building an image, right, and then run the container. Run the container in his or her environment itself to test that application is running fine. Once the application is working fine, some kind of automation tools like Jenkins can be used by the organization to do things like unit test, right, integration test, right, and then use the deploy, which is a continuous deploy, right. From there, once everything is done, from the image to the automation done by the Jenkins, image is being pushed to the registry, right? Registry is a space where the final the final application image is being stored. This could be on-prem or this could be in the cloud, right? And then once the registry once we have a new image for a particular application, the operations team can finally put it into the production environment. So here we have shown that the quality assurance, they call it the QA engineer, test the registry as per the guidelines, and if it is onto the mark, it is being pushed onto the production environment. But in case there is any information, if in case there is any bug, right, the information can be given back to the developer to correct it, right? So some kind of case management solution can be used to pass on the information back. So here you could see that all the way from writing the code to automating the code for unit test or integration test or a system test, right, and all the way putting through QA to the production is being done through this code to production cycle per se. Now what happens is that this code to production or this CI/CD pipeline, right, essentially brings a set of challenges in itself, right? Or we generally say that it increases or it introduces a new attack surface, right? And that's where we are highlighting that in the CI/CD pipeline itself, right? The challenge could be the developer using the open source software could have a bug or could have a vulnerability associated with it, and that vulnerability is being ignored and a build is created, right? And when this is stored in the registry, and when it is stored in the registry, it can be directly pushed to the production environment, right? So unless we have a mechanism to identify the vulnerability in the CI/CD pipeline itself, it would be very difficult for us to handle the situation when that particular Docker actually runs in the run environment, right? So we could shift left and extend the security to our customers by identifying critical vulnerabilities during the CI/CD pipeline. And this could be done by introducing some kind of a security configuration. But introducing this security checkpoint can actually slow or even stop the continuous integration process, right? So we need to probably think of something else, right? And then we talk about, I mean, misconfiguration perspective, right? Uh, uh, the misconfiguration is probably the number one thing, right, which leads to compromising the security, right? And in addition to it, we are using uh, various automation tools like Kubernetes, Docker itself, which could have the vulnerability. Jenkins, for that for that matter, which could have their own set of vulnerabilities, right? So all of this is increasing the attack surface, which has to be taken care by the customer who are embracing the Docker container or the container environment per se. For this, customers deploy various set of security solution, all the way starting from vulnerability management, or from the compliances perspective, they have the runtime security. They do still continue with the network security in terms of a web application firewall, and so on and so forth, right? So customer have to use various different set of siloed product to mitigate the threat being posed by this new paradigm. And that's where the Palo Alto comes into the picture. Palo Alto has got a solution known as Prisma Cloud Compute, which help identify the vulnerabilities during the build stage itself, right? Identify the vulnerabilities when we are shipping, or when the image is running in the registries itself, right? And ensure that if a image has got any kind of a vulnerability, it will not let that image run in the production environment. And when the container is running, so let's say we have covered both the two phases in terms of build and the ship. But when the container is executed, when the image is executed and container is running, at that time there was a small portion of a code which start behaving malicious, and it start establishing some connectivity to the outside world, right? That's where the runtime security into the picture. So Palo Alto's Prisma Cloud Compute solution covers all the three phases and extends security to our customers. So rather than looking at various different set of uh, solutions like vulnerability management, runtime security from various organizations, they can just look at Prisma Cloud Compute, which would help them cover all the three stages. So I think with that, I have come to the end of my presentation, and I think I'm right on time. So if there is any question, I'm happy to, I'll be happy to answer those questions. Jeet sir. Hello. Yeah, Anurag, I think you have a question.
Hello.
Yes. Yeah, please tell me. Jeet, you are on mute. In fact, I mean, I can see you on mute. Pradeep sir, are you there on the, are you there? Are you still there? Yeah, so probably you might have to unmute Jeet. Yeah.
Hello.
Hi, yeah, hi Ajman. Tell me.
Hello, that was an wonderful presentation, sir.
Thank you.
I have one question that what is the role of a data analyst in there?
Um, um, so data analyst, I don't think so. It has got a direct connect with this particular section which I have covered about, right? This is more of like from the information technology per se, but nothing related to the data analyst. I'm sorry for that, but yeah. Pradeep, can you unmute Jeet? I think he's trying to unmute himself. Looks like. In case you are guys,
Yeah.
in case
Hello,
yeah,
sir. Can you listen to me?
yeah, yes.
Yeah. Thank you, sir. Thank you for your patience, sir. Sir, gradually we have some questions and we'll take them one by one. So I would
Sure.
request Pradeep, sir, if he can unmute uh, Anurag or Arjuman. They were initially raising hands. They have questions. Gradually, I can ask you a few questions.
Yeah.
Uh, the first one is how COVID-19 affects the employment and growth factors of the software industry worldwide and especially in India, sir.
So if you really ask me, right, from the COVID-19 perspective, it has not at all impacted the IT industry per se, right? And in fact, it has given IT an opportunity to extend its support and help the community, right? I mean, in terms of still remaining productive. I will give you an example right over here.
Okay.
Uh, uh, with this COVID-19 thing, and then government mandating people working from home, right? Suddenly, organization realized that how are they going to make their employee productive while they are at a home, right?
Yes.
They never thought of this situation in the past, uh, but then the IT industry, right? Organizations like Palo Alto, right, and rest of the other organization very quickly, swiftly came out with the solution to ensure that that the employees can securely work from the solution from home. So on this front, like I can give you an example from the Palo Alto perspective. Palo Alto has got something known as security as a service. It is a SASE based solution, uh,
Yeah.
which actually allows employee to securely access the infrastructure, their data center, their services while sitting at a home and still be productive, right? So I don't see that COVID has, in fact, in fact, it has made us work more because uh, uh, we are there and then we are kind of always available.
Okay. And sir, next question is from. So the next question is. So what are the different security aspects of web designing? You have already talked about it, in your last part of your presentation. So if you can give us a summary, what are the security aspects of web designing?
So I would say that, I mean, web security is the most critical aspect of securing an organization today, right? We are in the world where all applications are web 2.0, right? Days are gone when we used to have client server based application. Today, all application are web facing, right? Which means that consumer access the application through websites, right? And everything has converged to HTTP as a protocol per se, right? Whether it is a port 80 or whether it is a port 443, which is a secure form of the HTTP protocol. So which essentially means that from the web security standpoint, uh, again at a two level, one from the development level perspective, we have to ensure that we don't introduce vulnerabilities onto the website by virtue of leveraging our experience and hardening the websites itself, right? That is one. And second is in terms of having solutions like web application firewall which help application protect from any kind of SQL injection, cross-site scripting, or other kind of attacks which are directed towards the website. So web security, I mean, there is a whole lot of thing. I mean, that's where the industry is focusing on at this point in time.
Okay, okay. So you have probably answered most of the questions which we had. And can you just tell me how necessary is it to master Kubernetes for a fresh BTech graduate in 2020?
So I would say no. I mean, it is not mandatory, right? The concept definitely it needs to be understood. Container is something, I mean, just take it as this way, that we have transitioned from the world where we used to have a dedicated server and dedicated application, and from there we went to the virtualization, right? By running some kind of a hypervisor and we virtualize. I still remember those days when people used to say that no, it is not going to work. It is good enough for the development environment. It can never ever be converted to a production environment. But look today, 99% of the organization have adopted the virtualization and they are running some or the other form of a virtualization in their environment. Similarly, today we are looking at a little bit of a pushback in terms of container, but then yes, there are benefits associated with the container. They are immutable in nature, right? They are very fast. They are very less source intensive. But then yes, there are certain challenges around it as well in terms of standardization of it, right? So probably understanding the concept of what container is, right, and things around it is good enough. Mastering Kubernetes will not happen till the time you have a hands-on experience, or till the time you are into that particular environment per se, right? So I would say just have a high level understanding about it.
Okay, sir, we have one more question. We have seen that you have shown layering concept for dockets, right? So what is the significance of this layering? Actually, students have read layering concepts in OSI model in their networking classes. So is it same, the significance of layering? We are asking you about the significance of layering in the Docker. If you
Yeah.
can kindly explain.
Yeah. So layering, what we have learned in OSI was more from ensuring a connectivity between the two physical hosts. When the two hosts talks to each other, there is a physical layer, there is a data link layer, there is a network layer, and in a phase way, in a layered way, the application talks to each other, right? And the idea was to bring a lot of standardization at a physical layer, at the data link layer, so that application can directly talk to each other irrespective of what is the underlying infrastructure there, right? I could have a I could have a network card from two different OEM, right? I could have Ethernet on one side and probably a coaxial cable on the other side. The idea was to essentially extend the communication between the two application, right? Now, when I talked about layering within the container, that was about that was about how can I benefit out of this new mechanism of writing a image, right? So, okay, let me just step back. So, in virtual machine, as you know that in a virtual machine, there is an operating system. Let's say there is a Windows operating system, and then on top of it, we run IIS or a Apache, right, which is our web server, and then on top of it, we run some kind of a application, right? So this is what we do in the physical machine. Similar to that, in the Docker also, in order to reuse the uh, various already running environment is where the layers comes into the picture. So if people can recall that in that particular slide, I had a layer and I said that in the layer, the base layer is a base image, which is a which is a leaned operating system. So generally, it is a leaned Linux environment, right? And then on top of it, I am running Ruby, which is a middleware, and then on top of it, I'm running OpenSSL, and then my actual code, right? Benefit of layer is that when I have to spin another container, right, of that same image, rather than running the operating system, the base operating system, and the Ruby again, I can use those layer in the second container and just run my container, just run my application code. So that is the benefit container does.
Okay, okay. So now we will request the students from the audience to please raise hand and ask questions to Mandeep sir. If you have any query, doubts or questions regarding the session, kindly raise your hands and ask questions to Mandeep sir. Yeah, Anurag, please ask your question. I would request Pradeep sir to unmute Anurag.
Hello, sir.
Yeah, Anurag, please go
Uh,
ahead.
Sir, I'm intrigued by pods. What do they possess, and like, what is the significance?
The pod.
Yes, sir.
Okay, all right. So pod is a terminology, right, which has come to us from the Kubernetes world, right? So if you really
Yes.
see, Docker is just a Docker is a Docker container, right? And I have been talking about word container, container, container. But the moment I switched my slide deck from Dockers to Kubernetes, immediately started talking about the word Docker, the word pod, right? I mean, this was just a 1 hour session, and 1 hour is not good enough to cover detail. I mean, while I was very interested in covering in detail, but 1 hour is not good enough. What Kubernetes does is that Kubernetes brought little bit of changes into the way container runs in the Kubernetes world, right? So they came out with this concept of a pod, which is a logical, containerization of having container associated libraries and another set of dependent Docker, another set of a dependent container running in it. Let me just give you one example. So let's say you have an application, right? And that application you have, you have basically put it in form of a container. But then you have another requirement that this container should only run when I should check that this particular services is available, right? And for that to happen, you have again created another container, which comes up, check the connectivity, respond to the primary container, and goes off, right? That's where the pod come into the picture. So pod has one or a more container running in it to meet the requirement, of the developer per se.
Okay. Thank you very much, Anurag, for your question, and thank you,
Thank you
Mandeep
so much,
sir.
sir.
Next, anybody would like to ask a question? We can take 1 or 2 questions at max. Anybody who would like to ask? Anybody would like? Hello, Anurag, can
your
you
voice
please
is not
mute yourself? Yeah, Anurag, can you please
Sir,
mute yourself?
I actually have a question.
Yeah, who's this? Please introduce yourself.
I'm Anurag Patnaik. I'm Anurag Patnaik, sir.
Okay, you please go forward. Then we'll take the question of Suman
Hello.
Chakrabarti. Okay. Yeah, please go forward, Anurag.
Sir, I want to ask that. Sir, I want to ask that what is the way because if someone get
Anurag, I think your voice is breaking. So can we please switch to Suman Chakrabarti?
Anurag can type his question, in fact.
Yeah. Anurag, you can type your question. Mandeep sir can answer. And meanwhile, Suman Chakrabarti, can you please ask your question? We'll request Pradeep sir to unmute Suman Chakrabarti. Yeah,
Good
Suman,
evening,
you
sir.
are live.
Yes, sir.
Yeah.
I'm Suman Chakravarti. Sir, I want to ask that how the Kubernetes is uniquely different from other container technologies.
So if you really see from the container perspective, right, primarily there are 2 to 3 Renode OEMs in the container world. One is a Docker, and Docker has got its open source also, and then they have the commercialized version of it also. Second is the Rocket, and third is your container D, right? So these are the 3 prominent uh, container runtime OEM in the industry today, with most of the market, with the Docker, right? I mean, since they came early and people got to know about it, so their adoption is high with respect to the other. That is number one. From the orchestration perspective, Kubernetes is the one, right? Docker Swarm is the other, and then there are others also, right? So I mean, I remember the 2 OEM at this point in time, but again, Kubernetes is number 1 again.
Okay, thank you.
Okay. Okay. Thank you. Thank you, Suman, for your question. Next, I think we can end the session. It was great listening to you, Mandeep sir. You have touched upon many.
There are a few more questions. One is from Vishal Das. And,
okay, Vishal.
Yeah, I am fine. I mean, till the time, I'm fine. Yeah.
Okay.
Hello, sir. This is Vishal Das.
Yeah. Hi, Vishal.
Yes, sir, I'm a final year student. So you talked about various developer levels and cloud services. So I just want to know that as the IoT, artificial intelligence are the hot topics in present and the future. So what is the opportunities and the main target of AI and machine learning in terms of cloud services?
So I think there is a huge amount of focus from the IoT perspective at this point in time, right? And I mean, when we present to our customer, we do talk about that. I mean, millions devices are getting hooked on to the internet per se, right? And these IoT devices or these IoT devices needs to be managed, right? And some kind of analysis being done onto it, and that's where various solutions are coming into the picture, right? Which are running artificial intelligence and machine learning per se, to identify some kind of a threats, right? So for example, from the Palo Alto perspective also, right, to identify threats associated with the IoT devices, there are various solutions. Like, I mean, we just bought a company called Zingbox to identify threats associated with the IoT devices. So definitely a huge focus. First, industry transition, adopting IoT. I mean, moving their OT devices, hooking onto the internet per se, and then running a lot of artificial intelligence, machine learning to identify threats associated with them. Yeah.
Okay, sir. Thank you, sir. And another one question I have, sir. There are many more cloud service providers such as IBM, Microsoft Azure, then Google Cloud Service Provider. So, if we compare the such cloud services, which one is better for use or user friendly?
No, I mean, I think, I mean, all are good. I would say that the three prominent the cloud service provider at this point in time is AWS, Azure, and GCP, right, which is the Google one. Each one has got its own set of strength and weaknesses per se, right? I mean, so, I mean, mostly it is AWS, right? But Azure and GCP is also picking up parallelly, I would say.
Okay,
Okay,
sir.
Vishal,
That's all
thank you
for
for
me.
your question.
Thank you,
Thank
sir.
you, Vishal.
Mandipji, there is a, I think Anurag Srivastav has, is back for the question. Before he asks, I wanted to know something, and it's on behalf of the students. So Mandipji, what should I do in order to, how can I, what should I do to, make myself ready to work for Palo Alto Networks?
Yeah, I think it is a good question. It's a great question. Uh, from the security standpoint, I would say that, I mean, there is a plenty of opportunity for the students, right? I mean, you must have definitely read in the past also that the scarcity of people understanding security is there. So when we have to hire employee, at time it takes much longer time to identify the person with the good security background, right? It is at time it becomes very hard to find, right? And it and because of that it becomes very expensive in nature as well, right? So so I would say that I mean getting onto the security field in the early career, right, with the right set of exposure ensures that student achieve their goal very early. I mean, that is what I feel, right? I mean, they need to have the understanding about the security. That this could be related with nitty gritties of I mean, how things work, what are the issues related, what are the security issues related with the with the I mean, various components, right? How to protect them and have some exposure, and then it is very easy.
That's very helpful. Thank you.
I would like to ask you one particular question. That is, you have done a lot of certifications, as it is very clear from your profile. Lot of certifications. So, can you share with the students which certifications among these, or what are the certifications they should go for to become industry ready in the next 1 year or so?
Yeah, so I think it will it do depend upon their interest, right? But with me and with my networking background, I would say that I mean, one has to be absolutely clear that which path they wanted to, whether they are whether they are going into the software development or they are going into the networking world. Now, within the networking world also, are they going into the pure networking space, or they wanted to pursue a career in network security? So that visualization has to be there in the mind of the student first. Once they have picked the track, then probably they can go for certifications. For example, right, I mean, from the networking perspective, right, from the networking perspective, Cisco's CCNA, CCNP are good to start with, right? And they can even do CCI. I have at this point in time seen that there are various new joinees or the students, right, I mean, who have just cleared their engineering, have already done the CCIE. And CCI is a testimony of students understanding a thorough understanding about the networking, right? They might not have a physical exposure, they might not know the deep into it, but at a high level they have the knowledge, right? And that knowledge can be appropriately used by the company, and once the exposure is given, it is like, absolutely clear. Similarly, from the security standpoint, again, one has to understand that are they looking at going into some kind of a SOC analyst profile, right? Or they wanted to get into a technical sales type kind of a role, right? Now, when we talk about SOC analyst working in a SOC, again, which is a very tough job, and which is, and it is very hard to get people a good SOC analyst per se. Things like certified ethical hacking is bare minimum thing to do with, right? And from there they can take it on further.
We have a question from Anurag Srivastav.
Hello, sir.
Yeah, Anurag.
Yeah, I asked you regarding pods. Sir, I saw another entity, kubelet, in your presentation.
Yeah, yeah. So kubelet, kubelet is essentially, I would say, a component uh, of Kubernetes which runs on the worker node. So Kubernetes has got two main server types. We call it as a master node and a worker node. Master node has got all components running associated with orchestration and management of the cluster itself. And worker node is the one where you have the runtime, whereas like, Docker and the Rocket comes into the picture. Now, this worker node know nothing, right? Worker node needs to get direction from the master to spin a container, or to shut down the container, right? To start using the network or stop the network, right? So and so forth. So kubelet is that component through which the worker node communicates to the master API server. So master API gives the instruction, and kubelet is the one who is responsible for executing that onto the worker node.
Okay. So
Got it, sir. Thank you so much.
Okay, great. I am reading out a question from Anurag Patnaik, who is writing. I'm trying to relate as much as I can. He's writing, how about if someone accesses the server and injects a malicious file, there might be some encoder that can bypass the firewall. How will our security persons be guarding our data at that time?
Yeah, I think so that's where the multiple tiered architecture, tiered layer security, defense in depth comes into the picture, right? So when Anurag is saying that the malicious code has been dropped, which essentially means that the attacker was able to bypass the perimeter security, whether it is a next generation firewall or it is a web application firewall, right? So which essentially means that attacker got enough of visibility into the environment, as to what kind of environment is that, what kind of vulnerabilities are associated, what vector can be used to drop the malicious code, right? Now assuming that malicious code is already there, bomb is not a bomb till the time it explodes, right? So so if a malicious code has has got dropped into the server, it is not harmful till the time it start establishing a connectivity to the outside world, to his master, for further instruction, executing something and exfiltrating the data. That's where things like identifying the command and control channel comes into the picture, and 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 blocking that particular channel, right? So if you really ask me, there is a kill chain, right? There is a MITRE framework around it also. There is a kill chain, and kill chain has got various stages. One is a reconnaissance attack, one is reconnaissance, second is about Second is about getting into the environment. Third is about the exfiltration and so on and so forth, right? So there are around 7 odd stages in the kill chain. If we could break any stage of the kill chain, we will be able to protect our customer. So let's say for whatsoever reason we could not protect our customer from getting a malicious code landed onto the server, that's okay. But if we could identify the moment the code is executed and it tries to establish a connectivity to the outside world, if we could if we could detect it and block it, we have still succeeded and we have still protected our customer. If we could not, then the attack is successful.
Okay. So thank you, Anurag, for your question, and thank you, Pradeep sir.
There are no other questions, and I think we have overshot our time. It's 6:35.
Okay. So, sir, can we end the session over here? Mandeep sir and Pradeep sir, can we end it over here today?
Yeah, sure. Thank you. I mean, I wanted to thank you for the opportunity. I mean, great audience, and they patiently heard me. 1 hour was not good enough, but nevertheless, I tried my best to deliver as much as possible. I mean, covering all the way from where the industry started to the container in 1 hour is not good enough, but I tried my best. Nevertheless, I am available, right? I mean, and in subsequent such kind of a webinar, I can cover, I mean, if there is anything specific, if the university wanted me to double click on something specific, I will be available.
Okay.
It was a great pleasure having you with us, Mr. Singh. So it was wonderful to hear you. I was just going through all the comments that were there in the YouTube channel as well. So a lot of people really felt that you have in your session they really learned a lot, heard a lot of very interesting things, and it was very inspirational. Thank you very much, Mr. Singh, on behalf of Adamus University.
Thank you so much, sir. Thanks. Really appreciate. Yeah.
Thank you. Bye bye.
Thank you.
We will close the session now.
Yeah. Bye, sir.